Hi. So you're used to working with information stored in nice little tables, just like Excel or SQL databases. You probably know exactly what I mean. Rows, columns, neat and organized relational stuff, right? But now, for some reason, you're thinking about jumping into the world of graph-based logic. To make it fun, let's create an example from Lord of the Rings. While I explain, I'll quickly create two super simple tables on screen, one for characters and one for items. Each character has a unique ID, and each item references its owner with another ID. All seem pretty straightforward, and the need for using another kind of database or data structure seems redundant. But imagine expanding this scenario. What happens if your tables get really big, like really big? What if you add Aragorn, Sauron, Saruman, and all the other characters, along with thousands of items, places, and complex connections between them? Spread across separate tables, of course. What if you end up with 5 tables, or 10, or even 100? Let's make it even worse. Imagine you have multiple siloed databases like these, each stored separately, with its own way of naming things. What if someone accidentally made a typo in a name or a place? It becomes a headache just to answer even basic questions, just from trying to join all these together, let's say. So, tables are fantastic, I really mean it, but as your data grows, sometimes they're just not enough. And with how fast AI is progressing these days, we need something better. That's exactly where something called Semantic Technologies and RDF comes in handy. RDF stands for Resource Description Framework, but who cares right now? Just think of it as a super clear and easy way to describe facts, exactly how we humans naturally speak. And importantly, it's also directly readable by computers. To make things simple and colorful, I'll use a friendly free online editor called RDF Sketch, but feel free to use any tool you like. Now, to write these human-like facts in a way that computers can understand, I'll use something called Turtle. It's one of several ways to write RDF, but Turtle is especially friendly, simple, and easy to learn for beginners. There are other formats too, like Manchester syntax. Let me know in the comments if you'd like me to cover them in a future video. Before we start, let's say a few things. First of all, entities aren't just names or strings. They're actual things in our little database world. So when we talk about something like Frodo or the One Ring, we're not just writing their names. We're creating real things that our data can refer to, work with, and link together. Now, for these things to be clearly recognized, not just by us, but by any computer anywhere, they need a proper name. And not just any name, they need a unique name, like a digital fingerprint. That's called a URI, which stands for Uniform Resource Identifier. Think of a URI like a very specific full address. If someone gives it to you, you can go straight there. Same with a URI, and it tells the computer exactly where the thing lives in our data. Now, the good news is you get to make your own. They can look like websites. In fact, they usually do. And they can include your domain and even a little tag that says what part of the world we're in. So for this example, let's agree to use a simple base URI. http thesemanticowl.org/lotr hash. If we break it down, it starts like a web page. Then we've got the Semantic Owl, which is also the name of the YouTube channel. Totally intentional. A little promo to help it stick in your mind. And finally, LAR tells us this entity is part of the Lord of the Rings data. The hash in the end is a special symbol that separates the base from the specific thing, like Frodo. So if I write http thesemanticowl.org/LOTR hash staff, I'm giving the staff a proper address that a computer can follow and understand. And of course, I enclose it in angle brackets. But why is the entity red underlined? Well, the answer is simple. It's incomplete. Turtle expects a full subject, predicate, object structure, like a full sentence. So the editor is basically saying, hey, you started with a subject, but you didn't tell me what you want to say about it. To fix that, I'll complete the information using what I already know from the Excel sheet. And the first thing I know is that this entity is of type item. So here I'd like to pause for a second and say, don't worry, you don't have to memorize this long w3.org URI that means type. Most editors and tools already know about it, and they'll often auto-complete it for you or even include it by default when you use the RDF : prefix, which I'll show you in just a few minutes. But you might be wondering, wait, what happens if I just invent my own semanticowl.org/lotr hash type property instead of using this one? Well, technically, yes, you could define your own version, something custom, but honestly, that's not a great idea. It's like trying to invent your own version of the word is a in English. Totally unnecessary. And the deeper reason is this. RDF is all about interoperability. The goal is for different tools and systems to understand each other, even if they weren't built by the same people. When we all use the same standard vocabularies, everything just works better. So even though RDF is super flexible and lets you define your own properties, when there's a well-known standard one, like type, it's always best to reuse it as is. And like I said, most editors, libraries, and reasoning engines already know what it means. So let's continue adding information about staff. That's why we're using a semicolon here instead of a period, because we're still talking about the same subject, the staff entity. Now I'm saying that staff has a name, and I'm writing it like this: has name staff in inverted commas. Again, there are other ways to say the same thing using well-known URIs, ones that are commonly used and mean the same thing. But just to keep things fast and simple for the rest of this transformation, I'm inventing my own properties, and that's totally okay. Later on, if we want to make our data more compatible with other systems, we can just link our custom property to a standard one. That's a patch that helps with interoperability, which basically means making sure different systems can understand each other. Let me know in the comments if you're interested in diving deeper into that topic too. Before we continue, notice how the red underline disappeared once I finished writing the full triple about this subject and added a period at the end. Now, to keep things quick and tidy, I'll just copy what I wrote for staff and reuse it to declare the other two item entities, just changing staff to bow and the one ring. All right, time for prefixes. Remember earlier when I said you don't need to keep typing that long base URI over and over again in Turtle? Well, this is where prefixes come in. Instead of repeating http thesemanticowl.org/LOTR hash every time, we can declare it once at the top and then just use a short nickname for it, like LOTR. It's kind of like giving your base URI a cool little shortcut. In Turtle, we do this by writing something like a prefix lot or colon and the base URI closed in angle brackets. Notice it starts with at and the word prefix in lowercase. That's Turtle style. SparkQL uses a slightly different way, but I'll show you that in another video. Also, take a look at how the editor helps us out here. It automatically applies the prefix to the items below and even adds a few common prefixes like RDF, RDFS, and SH, even though we only really needed RDF for now. No problem though, the others can stay. And check out how the color coding really makes the file easier on the eyes. Just a little touch that helps a lot when reading or editing your data. All right, let's keep going and transform the character data from table into RDF. Using the LOTR prefix I said earlier, I'm going to create the entity Frodo. I say that Frodo is of type Hobbit using RDF type, just like we did for items, and that he has name with a simple string and has age with another string. I've put 50 as Frodo's age. I mean, 21 feels a bit young when everyone else around him is like 2,000 years old, right? Hobbit problems. Now, pay attention here. Frodo also owns another entity, which I declared a bit further down, the one ring. So we're already starting to build connections between entities, and this is where RDF starts to shine. So let's make things even clearer. First, if I leave it here just 50 without specifying anything else, the computer treats it simply as a string, just a piece of text. And for a computer, 50 as a string is pretty much the same as Frodo or Hobbit. It doesn't really understand it as a number. That's exactly why we have these data type declarations, like XSD integer. When you write XSD integer, you're clearly telling the computer, hey, this isn't just any string, this is a number. And that's important because then the computer can actually understand the numeric meaning of 50 and do useful things like comparing ages, sorting numbers, or even calculations. Of course, to use it, we need to declare the XSD prefix at the top of our file. Again, no need to memorize. Also, look how it automatically changed color and the quotation marks even disappeared. That's the editor giving us a helpful visual hint. It's saying, hey, I recognize this as a real integer number, not just text. Now let's make another thing even clearer by giving a quick example. Imagine if I change this line. Lot owns Lotter the one ring to something simpler, like Lotter owns the one ring in string. Technically, this would still work and it's fine, but here's the catch. You'd lose the chance to add any extra properties to the one ring later on. Why? Because now it's just a plain piece of text, a simple string, and not an entity anymore. On the other hand, if you declare it as an entity, you can easily expand your data with more information like it's an item, it has the power of invisibility, it's made of gold, and so on. So keeping it as an entity gives you flexibility and power for richer interconnected data. That's why using entities with URIs instead of simple strings is usually the best choice in RDF. Now I'll transform the rest of the characters into RDF in the same way. Just a quick note, I noticed that this editor automatically converted RDF type into just A. That's simply a handy shortcut, widely used because it saves time and space. So there's no need to type out the full RDF:type every time. Keep in mind that this video is just meant to give you a friendly introduction and help you become familiar with knowledge graphs from the perspective of W3C standards and semantic technologies. It might also help those more advanced among you confirm that your assumptions were correct. This isn't a guide on how to programmatically transform data from Excel or SQL tables into RDF. That's an entirely different topic. If you enjoyed your time, please like, subscribe, and share this video with anyone you think might be interested, and let me know in the comments about topics you'd like me to elaborate on.